Today we will discuss about seafloor spreading. Seafloor spreading is a process that occurs at mid-oceanic ridge where new oceanic crust is formed through the volcanic activity and then gradually move away from the ridge. The idea that the seafloor itself moves and carried out the continent with it as it expands from the central axis was proposed by the American geologist Henry Hess in 1960. Now, what is the process which involves in the seafloor spreading? Seafloor is a geological process in which the tectonic plates, large slabs of the earth lithosphere, splits apart from each other. As the tectonic plates move away from each other, heat from the mantle conventional crust makes the crust more plastic and less dense. Seafloor spreading occurs at the divergent plate boundaries. As the tectonic plates slowly moves away from each other, heat from the mantle's conventional crust makes the crust more plastic and less dense. The less dense material rises above after forming a mountain or elevated area of the seafloor. Eventually, the crust cracks, the magma comes out of the rift valley. The process also includes the oozing out of the magma, the formation of rocks, solidification of rocks, and the formation of oceanic crusts, and the force which becomes responsible for oozing out of the magma and its formation inside the earth surface of the conventional grunts. Magma, because it is hotter and less dense, is forced up toward the ocean floor, cooling off when it touches water. When magma hardens, a small amount of new oceanic floor is added to the earth crust. As more magma rises and cools, it pushes the new seafloor away from the ridge. The process is known as the seafloor spreading. What is the mechanism now? According to this theory, the intense heat generated by the radioactive substances in the mantle below the Earth's surface seek a path to escape and give rise to the formation of conventional current in the mantle. Whenever the rising limbs of these currents meets, oceanic ridges are formed on the seafloor, and whenever the falling limbs meet, the trenches are formed. Seafloor spreading is the process that occurs in mid-oceanic ridge where new oceanic crust is formed through the volcanic activity and then gradually move away from the ridge. Seafloor spreading helps to explain the continental drift theory of plate tectonics. When the oceanic plates diverge, tensional stress causes the features to occur in the lithosphere. Now, what are the evidences which suggests us that actually the seafloor is spreading? Several types of evidences supports the his theory of seafloor spreading or the eruption of molten material, magnetic stripes in the rocks of the ocean floor, and the age of the rock themselves. The evidence leads to look at the continental drift theory. Now, the first evidence from the molten material. Rock-shaped pillar shows that the molten material has erupted again and again from the crack along the mid-oceanic ridge and cooled quickly. Evidences from the magnetic stripes. The process of magnetism. Rocks that makes up the oceanic floor lie in the pattern of magnetized stripes, which hold a record of the reversal of Earth's magnetic field. Now the evidences from the drilling samples. Core samples from the ocean floor shows that the older rocks are found further away from the ridge. Youngest rocks are in the center of the ridge. Now the recording of sonar signals. A device that bounces the sound waves underwater objects and then record the echoes of these sound waves. Sound wave echoes of the ocean bottom. The larger the sound wave take to return to the ship, the deeper the water is. Using the sound waves, the researchers discover an underwater system of ridges or mountains, the valley like those found on the continents. Now the aquatic animals, as the molten material is forced upward along the ridges, it brings the heat and chemicals that supports the exotic life form in the deep and oceanic water. The jet calms, mussels, and the tube worms get heated and chemical from the magma pouring out of the rift in the ridges. And the process of subduction, that is the process by which the seafloor sinks beneath the deep ocean trenches and back into the mantle, allow the part of oceanic floor to sink into the mantle. Subduction at the deep ocean trenches. Deep ocean trenches plunges into the deep underwater canyons and deep water trenches. Subduction is the process in which the ocean floor sinks beneath the deep ocean trenches and back into the mantle. Subduction in the Pacific and Atlantic. Deep ocean trenches are swallowing more oceanic crust than the mid-oceanic ridges can produce. Thus, the width of the Pacific will shrink. Atlantic is expanding. In the short trenches, it is a short trench. In some places, the oceanic crust is touched to the continental crust, which moves the continent. Mid-oceanic ridge, the largest chain of the mountains in the world. These are the divergence spread boundaries. We can just visualize the map where these trenches are formed and how they are formed. We have discussed it. Now the mapping of the area. If we see the mapping of the area, it suggests that the different continents are having ridges, from where the molten material is oozing out from inside the earth's surface and getting solidifying on the surface of earth, which leads to the separating of the ocean floor. Now what becomes the characteristics of the mid-oceanic ridge? The continents bordering the Atlantic Ocean, for example, are believed to move away from the mid-oceanic ridge at the rate of 1 to 2 centimeter, that is 0.4 to 0.8 inches per year, thus increasing the breadth of the ocean basin by twice that amount. Volcanic eruptions are common to all the mid-oceanic ridges, and they brings the huge amount of lava to the surface of this area. Rocks equidistant on either side of the crust of the mid-oceanic ridges shows the remarkable similarities. Rocks closer to the mid-oceanic ridges are normal polarity and of the youngest. The age of the rock increases as one moves away from the crust. The deep trenches have deep-seated earthquake occurrence, while in the mid-oceanic ridges, the quake foci have the shallow depths. Importance of seafloor spreading. Seafloor spreading helps us to explain the continental drift theory and the plate tectonic theory. Seafloor spreading propose that magma as the cause of new crust and the subduction of crust at the oceanic continental boundaries. This was further expounded by the scholars to propose the plates and their movement due to this magma. It is these tectonic plates and not the continents that have been moving since the inception of Earth. Thanks. Wish you all a nice day. Thank you very much.